Students, welcome to mathgotserved.com. In this clip, we're going to be taking a look at problems 6 to 10 of the Algebra 2 Common Core Regents exam for January 2017. Alright, let's take a look at question 6. It reads, which statement about statistical analysis is false? Now, if you notice, number 1 and options 1 and 2 are talking about experiments. Okay, what can they determine or suggest? And then option 3 and 4 are talking about observations, observational studies. Now, let's go over the difference between the two of them. One thing you want to note is that experiments are more powerful. Okay, they're more powerful in the sense that you can alter what you're studying and see what's your change, how your change impacts the outcome. Okay, on the flip side, observation is not as powerful as experiments, because for observation you can just arrive at conclusions, suggest association, patterns, or relationships based on what you see. It's basically hands off. Okay, so let's go ahead and write down something to note to help us answer the question, which is the distinction between experiments and observation studies. Okay, let's start with experiments. Experiments suggest association and determine causation. Determine causation. Another word for association basically is patterns and relationships. Okay, patterns and relationships. And you can think about causation as what? Cause and effect. Okay, cause and effect. That's what we're talking about concerning causation. So experiments you can observe, and then you can make changes and see what those changes, how the changes impacts the outcome. That's causation. And then what you can deduce from just observation is the patterns and relationships. Okay, so we see how powerful experiments are. Now, how does it differ from observational studies? Observational studies are not as powerful as experiments. Why? Because you cannot make any alterations. Okay, so all you can do with observation studies is suggest association. Okay, so with observation studies you can determine or you can suggest patterns and relationships. And that's that. You can't determine causation because you cannot alter what you're studying. Alright, so let's see which is the correct answer. We're going to go through all of them, okay? So the first one, experiments suggest patterns and relationships. That is association. Does experiment suggest association? Absolutely. So this is true. Experiments determine cause and effect. Causation. Do experiments determine causation? Certainly, because you can make changes and see how your changes affects the outcome. So cause and effect can be determined with experiments. So these two statements are true. Now let's look at option 3. Observation studies can determine cause and effect. Let's look at our notes here. Observation studies suggest just association. You cannot make any changes, so observational studies cannot determine cause and effect. So this statement is false. Statement 4, observational studies can suggest patterns and relationships in data. Absolutely true. Okay, that's association for you there. So the statement that's false about statistical analysis is option number 3. Alright, let's take a look at question number 7. It reads, the expression m squared over m to the 1/3 all raised to the negative 1/2 is equivalent to. So let's review our properties of exponents, the ones that are applicable to this problem. Okay, so we're going to review our properties of exponents real quick, and then we will use them to solve this problem. First one is the quotient of powers property. If you have x to the n divided by x to the m, a quotient of two powers with identical bases, all you simply do is you subtract the um, power of the denominator from the power of the numerator. Okay, so that's the quotient of powers property. Property number 2, this is the power of a power property. If you have a power, let's say x to the n raised to the mth power, your answer is going to be x to the nm. Okay, what this is telling you is that when you have a power raised to a power, you simply multiply the powers. Property number 3, what if you have a negative exponent? So let's say you have x raised to the negative n power, or let's make it, yeah, negative n will suffice. Okay, let's say x raised to the negative n power. If you have a negative exponent associated with a term, that term switches position either to the numerator or denominator based on where it was at initially. So in this example, it's in the numerator, so we reciprocate it and negate the exponent. So this becomes 1 over x to the n, reciprocal property of exponents. Next property is x to the n over m, rational exponents property. Rational exponents can be written in radical form. The denominator is a root, so we have the mth root of x to the n. This is one way of applying the rational exponents property, or it can be written as the mth root of x raised to the nth power. Okay, we're going to be using this option today, as you will see in the problem solving process. Okay, let's go ahead and get started. We have m squared over m to the 1/3 raised to the negative 1 over 2. So what we're going to do first is apply the quotient of powers property, which tells us that if you have the quotient of exponents with identical bases, what you do is you subtract the exponents like that. And of course, we have the negative 1/2 still out there. Now we express these two numbers as fractions. Now we have to express them as equivalent fractions with identical denominators. That requires that we find the LCD. Okay, the LCD of 1 and 3 is 3, so we need to change the denominator here to 3, and that will also alter the numerator. So that becomes, if you times this by 3 on the top and bottom, you have 6 over 3 minus 1 over 3 raised to the negative 1/3. Okay, now if you subtract, you have m raised to the, subtract the numerator and keep the denominator. Okay, raised to the negative 1/2, negative 1/2. I already changed it to 1/3. I don't know how that happened. Okay, so that's 1/2 right there. Now we're going to apply the power of a power property of exponents, formula number 2, which just basically tells you that you multiply the powers whenever you have a power raised to a power. So 5/3 times negative 1/2. Alright, so when you're multiplying here, what you're going to do is you multiply across. Okay, numerator times numerator, and denominator times denominator. So that's going to give us m raised to the negative 5 over 6. Next move requires the use of the reciprocal property of exponents. So with if you have a term of an exponent, with a negative power, you can reciprocate. So we reciprocate the entire term, and we take the opposite of the power. So it goes from negative 5/6 to positive 5/6 because we have reciprocated it. Now to finish off, we're going to apply the rational exponents property. This uh, exponential term with a rational exponent can be written as the root of a power. Okay, so it's going to be 1 over, the power is 5, the root is 6. So we're looking at the 6th root of m raised to the 5th power. Okay, so there goes your final answer. Answer for number 7 is option number 2. Okay, number 8. We are asked to find the inverse of y equals log base 3 of x. So you want to recall the procedure for finding inverses. Okay, so recall, to find inverse, or to find inverses, you do what? One, you switch the x and y's. Okay? Because when you're looking for the inverse, the output becomes the input becomes the output. So that's why you're switching the x and the y's. Alright? And then you solve for y, and that will be your inverse. Alright? So let's go ahead and apply that this procedure here. We have y equals log base 3 of x. Now we're going to switch our x and y's. Okay? So this y becomes an x, and we have log base 3, and this x becomes a y. Now to get rid of the log base 3 on the right, which will result in the isolation of y, we're going to make use of the inverse of logarithms, which is exponentiation. Since the base of this logarithm is 3, we're going to put a big 3 on the left and right sides of our equation. Exponentiate x, so we have 3 raised to the x equals 3 raised to the log base 3 of y. Okay? So what does that accomplish? On the right side, we have the exponent of a log with identical bases, their inverses, and cancel out. So your final answer, y, is equal to 3 to the xth power. Okay? Final answer for number 8 is option number 3. Alright, let's take a look at question 9. It says, Gabrielle performed an experiment to see if planting 13 tomato plants in black plastic mulch leads to larger tomatoes than if 13 plants were planted without mulch. He observed that the average weight of the tomatoes from tomato plants grown in black plastic mulch was 5 ounces greater than those from the plants planted without mulch. To determine if the observed difference is statistically significant, he re-randomized the tomato groups 100 times to study these random differences in the mean weights. The output of his simulation is summarized in the dot plot below. Okay, so there goes the dot plot. And notice what it is graphing. It's graphing the difference in mean weight. Okay, so keep that in mind. Alright, so let's consider the options. So the first one says there was no effect observed between the two groups. And now, if that were the case, then will there be differences? Would there be variation in the differences in mean weight? The answer is no. If there's no observable difference between the two groups, then there will be no difference in mean weight. Okay, so option 1 is absolutely false because we can see that there are observable differences. That's why I have the plots all over the place. There are observable differences in the mean weight. Option 2, there was an effect. There was an effect observed that could be due to the random assignment of the plants to the groups. The question is, did the re-randomization of the um, data, did it result in a change in the dot plot or this or the average? Okay, so if you take a look back at the question, the average was 5 ounce difference, 5 ounce greater. Okay, so let's go ahead and plot 5 ounce on our graph. It's midpoint between 0 and 10, so that's 5 ounce right there. So the question is, if you look at this dot plot, is the dot plot distributed normally about this average 5? Take a look at it. The answer is no, it's not normally distributed. Okay, so what does this tell us? It tells us that the random assignment of plant groups did impact the outcome. Okay, it did impact the observation because it is not it's not spread normally about the average of 5 ounce. Okay, so statement number 2 is true. This is an accurate conclusion that can be drawn. All right, let's take a look at question number 10. It reads, if p of x is equal to a times b to the x and r of x is equal to c times z to the x, then p of x times r of x equals. Now there is a property of exponents that we didn't touch on in the previous problem that we are going to be using today. Okay, we didn't touch on it when we're doing problem number 7, and that is the product of powers property of exponents. Alright, so let's go over what that is, and we're going to apply it in finding the product of these two exponents. That basically says that if you're multiplying two exponents with different bases and identical powers, you can rewrite it as ab raised to the x power. Okay? Alright, we're going to apply that here in a minute. We know that p of x is equal to a b to the x power. R of x is equal to c times d to the x power. So what is the product of p times r of x? We just simply multiply their exponential values. Okay, so we're going to be looking at ab raised to the x power times cd raised to the x power. Alright, so this can be written as a times b to the x times c times d to the x. Okay, so we know that multiplication commutes. The order that you write a product doesn't affect the result. So we can move factors around. So I can group a and c together. I can write this as a times c times b to the x times z to the x. Okay, using the coming to the property of multiplication. Alright, now we are going to group these last two products with identical powers. We're going to write it as ac times b to the x times d to the x. Now, do you see how this property of exponents can be applied in rewriting this quantity right here? It can be rewritten as follows. This can be written as ac times the product of the bases raised to the exponent. Okay, applying the product of powers property of exponents. So there goes your final answer. The answer to number 10 is option number 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable and supportive to us. If you have any questions about the contents of this tutorial or any math Regents question in general, just place your question in the comment section below and we will be more than glad to support you. Don't forget to subscribe to our channel for updates to other math tutorials such as this. More clips, including the solutions, can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.